This is sections E.7, integration by table. Now let's recall when we try to integrate, so I have some examples here, 1 through 6. Sometimes you've seen the integral that looks very familiar, right? Some of them I think we can do with, even though we can use different techniques. Like you see, that one is 4 minus x squared is there. Derivative 4 minus x squared is negative 2x. So you need negative 2x to do the u subs. So looking at this example, I see, well, that one I use u sub, let u be 4 minus x squared. Okay. Then you're looking at number 2. Well, I cannot u sub here because there's no x on the top because the derivative is negative 2x. But observe carefully, that is really the arcsine formula. So we're going to use the arcsine function there. Okay. And then for example 3, you have an x, you have an 4. So one way to do is you're going to split this into 2 integral, right? So you're going to have the first one, it's x over root of 4 minus x squared. And then the other one is just 4 over root 4 minus x squared, right? It's just split fractions. And that way, the first integral is root number 1, the second integral is root number 2. I don't have time to go over this. Basically, just a review. Again, it's not anything new. But when I have time, we often review it in more detail. So you should be able to do this with no problem. Now, look at number 4. Again, I'm trying to put these examples up so you can see they look very similar, yet the techniques were different. In 4, the substitution actually cannot be used when you have x squared instead of the x. And so 4, 5, 6, I think we end up having to use the trig sub. All right. So these are the techniques that we have learned and we can do with different techniques. However, in reality, you see that when integral looks similar and we have to repeat over and over for a similar type of integral, using trig sub, for example, it's very, very tedious. So what I'm trying to say is when we do this using the trig sub, whatever the integral, right, whatever technique we use, we can develop a formula. Okay, I'm saying the formulas to make things easier, and then we can reference it instead of do it over and over. For example, if you see most of these actually has root 4 minus x squared in the bottoms. Okay, so I can integrate this. Instead of 4 minus x squared, I can do just say general a squared minus x squared, maybe x squared on top. So and do this more in general, and I'm gonna do the same thing with the trig sub, but at the end you end up with something with a's in it, and then if a is 2 or 3 or 5, I can just replace using this same answer, replacing the a with the numbers I have. So then when you do that, each time you use the techniques and then you develop the formula, we put it in the table, and we're going to use that table of common integral to integrate without doing this over and over using the same techniques, trig sub. Let me show you quickly what I mean. So here's some okay, so the all right, so if you go to the website and then put out a book, and you're gonna see you go to Appendix B. Okay, so in the Appendix B, you're gonna have a whole bunch of formula. Okay, so you see these from Appendix B. Okay, and when you get to the Appendix B, okay, you have all these integrations, and these formula are put in they grouped it into a special category. So like the first one involving the power n, this one involving the linear form a plus bu, that one's quadratic, that one's a linear inside the root, and you have the sum of difference of square, sum for difference of square inside the root. We click on it. So these are the formula. Okay, so involving that form, and then you can see here square root of u squared plus a plus minus a squared. Right, so when you see this integral of that form, it gives you the answer. Basically, it's a formula. Okay, and then if you identify the u's and a, you can plug in and you got the answer. Basically, these are just the integration rules. But the basic ones, the one that we have learned and memorized, but these are more complicated, but they're common, and we don't memorize them. You just use the formula in the table and just apply it, right? So again, if you're back to here, that's involve tangent and cotangent. You click on this, then you have all the formula involving the trig functions. Okay, now at first you feel like it's quite easy to apply, right? So you can just do it, right? Just apply the formula. But because not the formula, the integral that we have look exactly the same. And so we have to do a bit of work. Okay, so here's a few comments. First, each of the formula you've seen in the table is actually derived from a technique discussed in this chapter, right? So whether integration by part, trig sub, u sub, whatever. So they're actually using the technique we have learned and just derive it. Number two, the table in this of the integral here is just a supplement. Okay, it's a supplement to the integration technique that we have learned. Okay, and that kind of gives us the shortcut to find many common integrals, and it becomes handy when we need to do some integration later on. When the setup, like the volume things that we learn, when in reality, the setup is what no one can replace, no computer can replace. We have to do it by understanding it, and then from there, after the setup, you can use technology, computers, calculators, the table of integrals to help us do the integration part. Now, the remark number three is the most important. It often involves rewritings, okay, rewritings. The integrand using substitutions before one can fit the integral to one formula in the table. So if you look at these, example, okay, number one, right? 5 over 2x root 3x plus 5. So how are we going to find it? Well, first you look at these, you see there's a square root. And this is 3x plus 5 is a linear. So this is the form of linear inside the root. So what you're going to do is going to look and find which one has a square root and there's a linear function inside here, right? Root a plus bu. Click on that. Right, so I have 16 through 22. Right, so which one fits? Well, the one that we have the root in the denominator. So it has to be the one within the denominator. So not 16, 17 maybe, 17, 18. See, 17, 18, 21, 22 all of those are in the denominator. However, the one we have here has 2x in front. So there's another variable outside the root. Which one? 17, yes. 18 has the power n. We don't have the power. That one, there's no variable outside. So it must be 17, right? 17. Look at that, 2x, that, right? So I'm going to use the formula 17. Now in 17, we have 1 over u times root a plus bu. Okay. So let me write the formula up here so you can see. Right, so looking example 1. Now example 1, we're going to use the formula. Right, so you need to reference which formula we're using. We're using the formula 17. And in the formula 17, we have the integral of 1 over u square root of a plus bu du. Okay, check that again. 1 over u root a plus bu. Now, does it fit? Well, if you look, a plus bu, and here is what's inside the root. So you have to identify what is a, what is b, and what is u. So the a, the constant, is in fact 5. The b is the coefficients, it's 3. And the u is x, right? So that match. Now, the u here, again, variable is the x. But we have an extra 5 and 2's outside that doesn't have. So technically, before you apply, you need to rewrite. So here's I'm going to rewrite. You take out the 5, take out the 2. I can do that factor of 5 and 2. So my integral become 1 over, right, x. Okay, let me rewrite this as 5 plus 3x. Right, 5 plus 3x. And in fact, let me throw the 5.5 outside of the integral. Now, do you see that? Exactly the same that we have here, right? 1x. So when I use the formula 17, the a is 5, b is 3, and u is x. Okay. All right. So all I'm doing here is copy the formula, right? So what this formula says. Well, this formula actually has 2 forms. It depends on a, positive or negative. Our a, remember a is 5, I think. So our a has to be positive. So it's going to be the first one. Okay. So we have 1 over root a. All right. So it is 1 over root a. A is 5 times the natural log. Look at the formula again. Natural log. Okay, absolute values. Root a plus bu minus root a. So in our form, root a is 5 plus bx, a plus bu, minus root a again is 5. Okay, again, just copying this. Replacing the a, b, and a with 5, 3, 5. U is x. Bottom's the same with the minus, change to the plus sign. Okay, so that is over square root of 5 plus 3x plus 5 absolute value plus c. And basically I'm done, but do not forget the 5 in front, right? So that is really 5 time, and that's the answer, right? So again, the first example is not too bad. All you do is find the correct formula and apply it. Now let's look at number 2. Now number 2, it's a bit harder. You have root x to the 6 minus 4. Now if you go back to the formula, root, square root, square root, square root, all the formula involving square roots are either linear or sums and difference of square, right? We don't have anything close to this because 6 powers, okay? 6 power. So that's just one thing. In order for that to work, you need to have the integral that has square root of something square. See the 4 here is a little easy to see, that is 2 square. So what I wish to have is the integral that might have something square minus, well, 4 is it's 2 square. If we had something square minus something square, then we do have the formula. Okay. Now that suggests we have to do is some substitution here, because if you want that to be something square, but we have x to the 6, so x to the 6 is equivalent to x cubed squared, right? X cubed squared is x to the 6. Okay, so in order to apply the formula, you need to have a substitution first, because I want this to be u, x cubed. If x cubed become u, then have u squared minus 2 squared, and then we have the difference square of that formula, right? So again, we're doing the formula substitution here. If you let u be x to the 3rd, don't forget that we do the u is 3x squared dx. And fortunately, I have the x squared outside. That actually makes it work. But before we get there, let's rearrange, right? So I have square root of, here's this x cubed squared minus 2 squared. We put the x squared in the back, that's the x. I need what? I need 3, so I'm gonna time 3 times 1/3. That will turn into a du. And now you have 1/3 can carry it outside, and it's become, okay, so you have equal sign here, it's an equal sign. Take that out, become integral, it's square root of u squared minus 2 squared. That u, okay, u squared minus 2 squared. Now that fit the form. Let's see. Well, let's find the form that fit perfectly. So now we have a new integral, square root of u squared minus 2 squared, in which one? Square root u squared. All right, look like the form u squared plus or minus a squared. Click on that. and all we have is u squared minus. Okay, so that precisely formula number 26, right? Nothing else beside the root, the difference of square there. See, nothing else, that one. So from here, we say we use, we need to again reference the formula. We use the formula number 26 there. 26, right? Formula 26. Okay, so let's write it in 26. With A is 2. In this case, we only have A. U is the same. All right, so just apply the formula, and that's equal to 1/3. See what the formula says. We have 1/2 u square root. Okay, so 1/2. So that's a third from here, but from the formula, that is 1/2, and then you have a square root of u and then square root minus. So I need to have the u first. Okay, so it is u times square root of u square minus 2 square minus. Notice that there's a plus or minus in the formula, but since we have minus, and so that's minus, so it's going to be minus, and it'll be minus, right? So it'll be minus 2 square natural log. Okay, it'll be 2 squared times the natural log of, and natural log u plus the square root, u plus and the square root of u squared minus 2 squared plus c. Right? So again, using formula 26, half u square root minus a square, half u square root minus a square natural log of u plus root u squared minus a squared. All right, so that's all we need. After you apply the formula, so that's already integrate, and all you need to do is simplify and do a back substitution here, since you have x. X to the third is the that one's there. Okay. And let's see, we have now right, so replace the u with x to the third, and this combines, so we got the answers. Here's the final answer after the substitute back. All right. Let's look at example 3. Example 3 here, we have 5 over 4x root 7 minus 4x squared, right? So if you look at this one, and you see, well, I have square root in the denominator, and it looked like it's a square there, right? 4x squared minus. So you recall all the formula that we have as the square root, either the linear, like ax plus b, or you're going to have the difference of square. So in order to use one of the formula we have, you need to find one that with square root of the bottoms and with difference of square. And so that suggests in order to find a formula that fits, you need to have something square minus something square there, right? Which means, okay, look at the 7 minus 4x squared. So you will need to have this. So what's square here? Give you 4x squared, right? It is 2x. 2x. Well, 7, you can think of 7 as root 7 squared. So again, here is a substitutions needed before you can apply the formula, right? So the integral now, I'm going to rewrite that as 5 over 4x times square root of 7 minus, that is really 2x quantities squared there. Okay, so that suggests the substitutions, and we're going to start with let u be, what is u in the case? It's 2x, right? So we want u to be 2x, and du is 2 dx. Okay, so with that said, then you will substitute in, I need the 2, right? So I'm gonna multiply this by 2, and then time it's a half. With the standard techniques, that could be written as 1/2. Well, let's take out the constants. I don't think we need the constant anyway. So you see, here's a 5 times 1 is 4 times 2. If we take all the constant out, I have 5 over 8, and then we have 1 over. So you see that one's du. So now you have 1 over, and that is du, and then you have square root of 7 minus u squared. Okay. Now the x, well, the x here, maybe you should adjust a little bit. You technically have an x there, right? You have an x there here. But since the change variable, I need to change it as well. Then 2x will become a u, right? So, well, I shouldn't take out the 4. Maybe think of this as 5/4, right, times 2x. Okay, so this 2x will turn into a u, right? So that turns into a u. So let me change the color. So you can see that becomes u, that's 7 minus u squared. You see, without even doing looking at the formula, I actually can see let me see here. So we have let's see here, what's the formula again? Let me see, looking at the formula, we're looking at square root of difference square, right? So click on that one. And which one? Okay, we have the one that's again in denominators, right? So we want one in denominators, and then there's a variables outside. So square root, square root, square root, this one in denominator, that one in denominator, but this is the sum. I think we can put difference square, so that is the one, number 33. right? U squared minus A squared. Again, you see we have a variables outside. So it looks like we're using the formula number 33, right? So use formula number 33 with, again, what's A in this case? A is square root of 7, right? Square root of 7. Okay. Now, by the formula, we have, this is 5/4. And I think it's ready to apply the formula here. 1 over u root u squared minus a squared. Oh, actually, I'm wrong. Am I? U squared minus a squared. We have a squared minus u squared. Sorry, it's not the right one. I almost picked the wrong one. This is u squared minus a squared, u squared minus a squared, u squared plus a squared, u squared minus a squared. We don't have the one a squared minus u squared. A squared minus u squared. Interesting. Right, so we picked the wrong one. Actually, the one we're looking at is a squared minus u squared. So we this instead. Yeah, my bad to look at the wrong formula. So we see a squared minus u squared with u in front in the denominator. Right, so that is number 42 instead. Right, so it's now 33. We are using formula 42, right? 42. And then look at the 42. What does it say? -1 over a natural log, right? So that's equal to -1 over a square root of 7 natural log of, and what's inside is a plus the square root over u. A again is square root of 7 plus the square root over u. Square root again is 7 minus u squared there, absolute values. Okay, so that is from the formula plus the constant. I think that's all. Then we just need to simplify a bit and do back substitutions. And here's I have a -5. So it becomes -5 over 4 root 7 times the natural log of root 7 plus square root of 7 minus 4x squared over 2x. That's the value plus c. All right. Now look at the example 4. The integral of tangent to the 6. See, this one is a bit different, right? The formula is involving the trig. So let's look up to see if we can find anything that with tangent. So we're gonna be in the form tangent, cotangent, secant, right? So these are the group. Now, which one? Tangent. Well, it's easy to see. Tangent there is the tangent square, and we have tangent to the n power. Okay, so it looks like we're using the number 67 with n is 6. Okay, So using the formula, again, we write on the side, we use the formula. What's the number again? It's 67 with, and the formula is the power n, and the power n is 6. Okay, right? So let's apply this. So this is equal, and the formula says tangent to n minus 1. So that's 1 is 1 less than this. Okay, so if it's 6, then it's going to be 5. The denominator is 5, and here is a tangent to n minus 2, so it'll be 2 degrees less. It's 4, right? So you see the power kind of go down 1's here, and then 2's there. So we have tangent to the 5th. So that's equal to tangent to the 5th of x over 5 minus the integral of tangent to the, remember that's n minus 2, which is 6, so it's going to be a 4. Tangent to the 4th, this. Right, so you see that one, this, okay. Now notice that in this case we still have the integral. It's just because this formula is derived using the integration by part, uv minus integral of v du. So you see that there's still an integral to take care. In our case, it's tangent to the 4th. Well, how to integrate that? We're going to use the formula again. So what formula? Well, it's still tangent to the 4th power. So it's still the power of n. We use the same formula again, 67. But this time the n is 4 rather than 6, right? So let's apply that again. Notice that I still have tangent to the 5th x over there over 5 minus. Now the integral here, when you apply, again, it's gonna be 1 degree less. This will be tangent q over 3 minus the integral, and then you have tangent square. That's 2 less dx. Okay. And then we have that integral to take care. One more, right? Tangent squared, but it's glad it's going down. Now, if you go check, you can use the same formula 67, but in fact, we do have a shorter formula here for the tangent square. It's 63, so we can use formula 63, right? Formula 63, right? So this integral would become tangent to the 5th of x over 5 minus, and this is tangent q over 3 minus time minus is positive. And then I'm using the formula here, right? The formula for the tangent square, that is what the formula 63. So negative u plus tangent u, 63. So we use, right here, we use formula 63, and the answer is negative u plus tangent of u. Think negative u plus tangent u. Okay, and of course plus constant. All right. So let me rewrite the answer here. So the final answer will be tangent to the fifth over 5 minus tangent to the third over 3. We will write that with the tangent come first. That tangent, I think it's the x in our case, right? So I'm using the formula u, but our variable is x, so that become x. Okay, so that is x tangent x minus x plus c. Right, so sometime you see we're going to use the formula more than once. Just continue to apply the formula until we got the answer. Right, that finished the 8.7, I believe.